Okay, here are some homework questions from page 88. First, number 23. Alrighty, we want to determine vertical asymptotes, if any. So we need to try to factor it. So the top factors with the x method. Take the time to make sure your signs are right. So do the actual x if you need to. And the bottom we're going to factor by grouping. So we get, I'm going to do it up here, x squared and x minus 5, and we get a 1 and x minus 5, so it matches. We get x minus 5 and x squared minus 1. So my x minus 5's cancel. So x squared minus 1 is going to give me asymptotes. You can either, since it's an x squared, you can either go ahead and set it equal to 0 here and solve by taking the square root, or you can go one more step and factor the bottom and set those equal to 0 and get your answer. 25. If we want to know these vertical asymptotes, I still sort of think I would want to put it in the calculator whenever sine pi x. But maybe we just need to, because the calculator wasn't super friendly today, I don't think. Let me try. I just realized I made a mistake on 23. If you go back with me to number 23, I messed up my leftovers. It should be x squared plus 1 here on the bottom. Please note my mistake. That means all of this was wrong, because it's a positive 1 here, so it should have been x squared plus 1. So you can set the denominator equal to 0. Take your square root and you get I. So no real asymptotes there, because that's imaginary. And we can't factor it more, so it's not a difference of squares. So this is kind of the only way you need to go, or you just need to think about it. There's no value that you can plug into x where you're going to get a 0 in the bottom. So there are no vertical asymptotes for this function. All right. 25. Yeah, let me check it on the calculator. Okay, I realize I thought too fast earlier today. Oops. So I put in y equals 1 over sine pi x for cosecant x, because they're reciprocals. And then I graphed it, and I think I was thinking about x-intercepts with second period today when I said, oh, it doesn't look like it crosses the x-axis. My mind just wasn't thinking in the right way. I should have been thinking about vertical asymptotes, and they're everywhere, right? Tons of vertical asymptotes. And if you check your table, you see errors at 2 and, oh, my table's wrong. So second table set, let's go back down to auto. Check our table. Look at all those errors. Errors everywhere. Or at those whole numbers. So by looking at the calculator, we're going to say we have vertical asymptotes everywhere x equals n, where n is an integer. Or we have vertical asymptote at all the integers. Alrighty, 27. This one, we're probably going to plug in the calculator also, so let me go ahead and do that. Okay, so we're looking at x over sine x. The graph, oh, we definitely have asymptotes. I checked my table and none immediately showed up. So let's go to the graph and let's just trace and just look at what happens. So as x gets, so if you see x is at like 2.7, 2.8, 3, 3.2, look at y. Oh, y's already down at the negatives. So x gets to 3 a little past, and then just a little past 3, it's down at negative 58. So we hit the asymptote right there, just a little past 3. So it's still going up. I still have x values, but a little past 3, we're down at the negative 58. So we're down under the graph, under the x-axis now. So we're working on this piece. So the same thing happens. X is 5.9, x is at 6, we're still negative. X is 6.2, we're still really negative. Sorry, and then at 6.3, we're positive now. So we're up on this portion up here. So somewhere around 6.2, somewhere just a little past 6.2, we left being at the negative value, and we're now up here at the positive value. So we definitely have asymptotes. Oh, 6.2, 3.1, maybe it's every pi, right? 6.28, that's 2 pi. So that would make sense. Let's back up and look and see what happens at 3.14. 3.04, we're still on that positive asymptote. See, we're up here approaching that positive asymptote. 3.19, we're down there on that negative portion. So I bet it's at every pi units we have an asymptote. And if you check the answer for 27, yeah, we have vertical asymptotes at n pi. As long as, if you look back at that graph, there was not an asymptote at 0. It was a funny looking parabola right there in the middle. It looked like at 0, so there was a value. So at n pi, as long as n isn't 0. Now, I believe, in my opinion, 23, 25, and 27, I told 5th period that I wouldn't be doing a whole lot of trig on the exam. And for all of you, I didn't assign a whole lot of trig questions on the practices, so these probably wouldn't show up on there. 45. More trig. Limit as we approach pi from the right. I would plug that into the calculator. And I would just look to see what it looks like. I might actually just say that's the square root of x times sine x. Take that cosecant x to the top. Then I might just try direct substitution. Square root of pi is a number. Sine of pi is negative, sine of pi is 0. So some number times 0 is 0. So direct substitution works on that one. And 51, I would probably do the teeny tinies. You can look at it on a graph if you'd like, but if we're going to approach 5 on the number line from the left side, we're looking at like 4.999. So that'd be the limit as x approaches 5 from the left of 1 over x squared minus 25. So let's just try to plug in 4.999. All right, that is a little less than 5. So a little less than 5 squared is a little less than 25. So this would be 1 over a tiny negative. And a regular number divided by a tiny number is an infinity answer. And a positive divided by a negative is negative infinity. And you could have also plugged that into your graph and looked at it. Okay, I have found IXLs for you all to look at. Nothing in particular, but 8.1 is nice, and lots of the ones on A, B, and C are good to practice. Maybe just try a few, see how you do.